Asteroid 2012 DA14 is an object about half the size of a football field in diameter that is going to pass very close to the Earth on February 15th. Coming from the south to the north, it actually gets to within 17,200 miles of the Earth's surface and will pass interior to the geosynchronous satellites and the GPS satellites. But there's really no chance of the asteroid hitting the Earth and very little chance it will hit a satellite. Although this object gets very close to the Earth on February 15th, it's fairly small as asteroids go, and it won't be observable with a naked eye, but if you happen to be located in Eastern Europe, Asia, Australia, and you know where to look, and you have a pair of binoculars, it will indeed be visible. The asteroid was discovered by a group of Spanish astronomers in La Sagra Observatory in southern Spain. An object the size of DA14 actually impacted the Earth on June 30th, 1908, the so-called Tunguska event. An object of about 30 or 40 meters came down into the Earth's atmosphere and exploded, leveling trees for 820 square miles. The close approach of this object 2012 DA14 on February 15th is nothing to worry about. Its orbit is very well known. We know exactly where it's going to go, and it cannot hit the Earth. 20 years ago, we probably wouldn't have found this object, but now NASA's observing the skies nightly and picking up these objects, and we track them for 100 years into the future and see if any of them make interesting close Earth approaches, not only because of the threat issue, but because these objects are important for science, they're important for future resources, as well as threats.
And the tool uses data on DA14 and allows us to track it in near real time. And Kevin Hussey is the manager of the visualization technology, and he is here to demonstrate how you at home can use it and follow along. Kevin?
Thank you, Gay. I am going to show you how you can, by going to this website, do everything I'm going to show you and recreate the simulation that you saw on the screen. So what appears to be a view of the solar system from above, looks like a textbook drawing, is actually models of the solar system and trajectories of our spacecraft and planets inside of a game engine. You can use your mouse, and I'm now going to click and drag my mouse, and you can see that I'm changing the position of the camera so it looks like I'm flying about our solar system. Anything that has a label is clickable. So before we get to DA14, I have a minute here. I'm going to take you out to Saturn, and we're going to look for another one of our missions that's currently active. There's the Cassini mission. Again, if you click on a label, we will take you to that spacecraft, and if you were at Cassini, this is how Saturn would appear to you at this time. All right, I'm going to take us back home, which will be the center of the solar system, and now I'm going to recreate that view that we showed you earlier. The Earth's label is obstructed by a DA14's label, so I'm going to double click on DA14 and take you into a view of the asteroid. When you double click on a label, we put a camera at the center and we allow you to move about. So right now we have what we call shadow lighting. It's semi-natural. I'm going to go ahead, I'm going to change the lighting model to a full-blown movie light. There it is, a floodlight if you will. I'm going to go ahead, I'm going to turn off the trajectories of the trails of the spacecraft, and I'm going to turn off the labels. We're getting closer. And then what I'm going to do is, there's a button here we've added that says Ride Along. So if you click the Ride Along button, we'll put the asteroid at the bottom of the screen. I call this the Bruce Willis view, and we can zoom in a bit. I'm going to go to 47 degrees, and you will be able to see this as you would if you were riding along with the asteroid. So with that, I would say that, remember, you can do exactly what I'm doing by visiting that website, and I encourage you to explore not only DA14 as it on its closest approach, but other objects and planets that are in our solar system. Gay?
All right. Thanks, Kevin. Well, we've been seeing...
And now we're seeing some from December 13th, around the time the asteroid made its closest approach. This is an example of what we can do with the Goldstone Solar System radar. We can get extraordinarily high-resolution images if the objects are close enough and big enough for us to see them like this. To give you a sense of what 4 meters really is, I'm about 1.8 meters tall, so the best resolution we can get with Goldstone is only about double my height.
But you're able to get so much more information.
On an object that's millions of kilometers away from us.
Okay.
Some dust?
Yes.
It'll put the sample.
DA14 is on its way, but we will continue our observations of it, and we will be seeing it here in the United States pretty soon.
This evening.
And so that wraps things up here. We would like to thank all of the observatories that helped us out today. That's Southern Cross in Tasmania, Sanford Valley in inner Brisbane, Australia, of course the Gingin Observatory outside of Perth, Australia, and JPL will continue to push out these images of DA14 as it moves over towards Europe and then over to the Northern Hemisphere and the United States, North America. You can see these images on our Ustream channel. That is http://www.ustream.tv and then NASA JPL2. And then later on today, NASA's Marshall Space Flight Center in Huntsville, Alabama, they will also be streaming images from their telescope. And you can see those here in the United States from 6 p.m. to 9 p.m. Pacific time. That'll be 9 p.m. to midnight. And you can search for their feed at www.ustream.tv, and that will be NASA-MSFC.